All right, we're going to find the exact surface area and volume of the region that's bounded by the following lines. So let's draw our boundaries in the x-axis, the y-axis. X is equal to -2, which is a vertical line, and y is equal to 5, which is a horizontal line. So the region that is enclosed by all 4 lines is this region here. And then we're going to rotate it about x is equal to 2, which is this line here. So I have a cylinder, or sorry, I have a rectangle not attached to the line that I'm rotating it about. So I'm going to be rotating it like so to where I have a cylinder with a cylindrical hole. That is what I'm finding the volume of. So, again, with the surface area, sorry. Surface area, okay. I'm going to find the surface area of the outside cylinder. So that's going to be 2 pi times my radius, which is going to be 1, 2, 3, 4 units, because that's the distance away from the line that I'm rotating it about. So 2 pi times 4 squared plus 2 pi times 4 times the height, which the height of my cylinder is 1, 2, 3, 4, 5. However, there is a cylindrical hole running through that cylinder. So I'm going to have to subtract these 2 circles here, which is going to be 2 pi r squared, which the radius of the hole is 2 units, what I just highlighted in green. And then I need to add on the lateral area of this smaller cylinder. So that's going to be plus a 2 pi, the radius of that smaller cylinder is 2, times the height of that cylinder, which is 5. So if I add or combine all this together, a 4 squared times a 2, plus a 2 times a 4 times a 5, minus a 2 times a 2 squared, plus a 2 times a 2 times a 5. I get 84 pi units squared, and it does say exact, so I'll leave my surface area just like that. Now I'm going to find the volume. And so I'm going to take the volume of the large cylinder, and then I'll subtract the volume of the small cylinder. So the volume of the large cylinder would be pi times 4 squared times my height of 5. And then I'll subtract the volume of the small cylinder, which is pi 2 squared times my height of 5. So I wind up with the volume being a 4 squared times a 5 minus a 2 squared times a 5. I wind up with 60 pi units cubed. And that's an exact format, so I just leave it just like that. Okay, moving on to my next problem. I'm going to find the surface area and volume of the region bounded by the y-axis. The line y is equal to -4/3 x plus 11. So this has a y-intercept at 11, and then I go down 4 and over 3, down 4 and over 3, down 4 and over 3. So this line here, the line y is equal to 3, and the line y is equal to -1. So the region that is connected to all 4 of those blue lines is this region here, and I'm rotating it about the y-axis. So this is what it looks like. So I'm really dealing with the frustum. So let's go ahead and let's finish off the top of the cone with a dotted line on my figure out here. Because with the frustum, we are going to need to deal with that top cone. So remember with the frustum, what we want to do is we want to take the surface area of the large cone, then subtract the lateral area of the small cone, and then add on this small base here. Okay, so let's get started. So surface area. I'm going to do the surface area of the large cone, which would be pi r squared. Well, my radius of my large cone is 1, 2, 3, 4, 5, 6, 7, 8. And then plus pi times my radius of 8 times my slant height, which I'm actually going to need to find right now. So 8 is my radius of my large cone. My small cone has a radius of 1, 2, 3, 4, 5. And then the height between the two is 1, 2, 3, 4. And the height of the whole thing is 5, 6, 7, 8, 9, 10, 11, 12. Which means the height of the small cone is 8. So now I have enough information to help me find my slant height. If I use the right triangle with the 12 and the 8, I would wind up with my slant height being the square root of 208, which we are going to need to simplify. 208 is divisible by 16. The square root of 16 is 4. And 208 divided by 16 is 13. Then finding the slant height of the small cone, because we'll need that, an 8 squared plus a 5 squared is the square root of 89. And the square root of 89 is actually not divisible by anything. So I just leave it as the square root of 89. Okay, so continuing on the surface area of my large cone, I need to multiply my slant height in. Now I'm going to subtract the lateral area of my small cone, which would be pi times the radius of that cone, which is 5, times the slant height of that cone, which is root 89. Then I add in the area of the base of that small cone, pi times 5 squared. So I can do the 8 squared pi plus the plus the 5 squared pi. That is going to be an 89 pi. Then the 8 times the 4 root 13, that's going to be a 32 pi root 13, and I cannot combine that with anything. And then, oops, minus, not plus, minus the 5 pi root 89. I can't do anything with that. This is my surface area. Okay, So now we're going to do the volume, which I'm going to do the volume of the large cone minus the volume of the small. So 1/3 pi times my radius, which is 8, squared, times my height, which is 12, minus 1/3 pi times my radius of my small cone, squared, times the height of that small cone, which is 8. So an 8 squared times a 12, times a 1/3 minus a 5 squared times an 8 times a 1/3 pi. I get a 189 and 1/3 pi units cubed. Okay, and then our last problem here. X-axis, y-intercept of 4, down 2 over 3, down 2 over 3. So this is the line that we're talking about here. X is equal to -3. And y is equal to 4. So the region bounded by all 4 of those lines is just this region here. We're rotating about the x-axis. So what that means is I'm rotating it like this. So I have a cone and a cylinder that's connected. So to find the surface area, I'm going to do the lateral area of the cone. The lateral area of the cone is pi RL, so pi times my radius, which is 1, 2, 3, 4, times my slant height. So my slant height of my cone, I'm going to find it using the Pythagorean theorem. My radius is 4, my height is 1, 2, 3, 4, 5, 6. So if I do a 6 squared plus a 4 squared, I get a 52. And a 52 is divisible by 4. So 2 root 13 is my slant height of that cone. Then I'm going to add on 1 base of my cylinder, so pi times 4 squared, plus 2 pi, this is still the cylinder, 2 pi r times the height of my cylinder, which is 3. So this is the surface area. So I have an 8 pi root 13 plus, and then I have a 16 pi plus 2 times a 4 times a 3 pi, so I get a 40 pi units squared. That's my exact surface area. Now the volume, I'm going to add the two volumes together. The volume of the cone would be 1/3 pi times my radius of 4 squared times the height of the cone, which is 6. Then I add on the volume of the cylinder, which would be pi times my radius of 4 squared times the height of that cylinder, which is 3. So when I add all this up and multiply it together, I wind up with 80 pi units cubed. All right, that brings us to the end of this lesson.